All right, in this video, we're going to introduce linear functions and calculating slope. So in this video in particular, we're going to look at calculating the slope of a line connecting 2 points. And for many of you, this will be a review video of prior math course knowledge. So the slope of a line connecting 2 points in the coordinate plane, P and Q, where P has the coordinates x1, y1, and Q has the coordinates x2, y2, is the slope of the line, which we use m, lowercase m, is equal to y2 minus y1 all over x2 minus x1, provided that x2 and x1 aren't the same point, because if they were, we would get a 0 in the denominator, and that's never good. So example 1, we're going to find the slope of the line connecting each pair of points. So we have 0, 0, the origin, and 2, 4. So you don't have to graph them, but if it helps, great, awesome. So our slope formula, y2 minus y1 over x2 minus x1, we'll call 0, 0, x1 and y1, and then 2, 4, x2 and y2. Although 2, 4 could have been x1, y1, and 0, 0 could have been x2 and y2. But substituting those values in, for y2 minus y1, we have 4 minus 0. For x2 minus x1, we have 2 minus 0, and that gives us 2. So to get from this point at the origin to this point at 2, 4, for every 2 units we go up, for every 2 units we rise, we have to go to the right 1 space. So our rise is 2, our run is 1, rise 2, run of 1, and we'll end up at that other point. So the slope acts as almost like a rate of change between the 2 points, something we'll talk about later on down the road. Part B, negative 2, 3, which is over here, and then 2, negative 3, which is down here. So once again, we have our slope formula. And substituting y2 minus y1, we have negative 3 minus 3. x2 minus x1, we have 2 minus negative 2. Be careful with your calculations. You get negative 6 over 4. So to get from this point to this point, you have to go down 6 units and to the right 4 units. Negative 6/4 simplifies to negative 3 halves. So for every 3 units we go down, we go to the right 2 units. All right, part C, negative 3, 2, and 4, 2. So here we have negative 3, 2, and here we have 4, 2. Notice it's a horizontal line connecting those 2 points. And applying the points to our formula, we have 2 minus 2 over 4 minus negative 3, which gives us 0 over 7, or just 0. So the slope of a horizontal line is 0 because there is no run, but there's as much there's no rise, rather, in the numerator, no rise, but there's all the run you could ask for. All right, part D, we have a vertical line here going through the points 2, 3, and 2, negative 1. So our slope formula, plugging them in, we get negative 1 minus 3 over 2 minus 2, and that gives us negative 4 over 0, which we know is undefined. So a vertical line has a slope that is undefined. Some people will say it has no slope. I don't like to say that because I don't want to confuse it with a slope of 0. But this one has all the rise you could ask for, but 0 of the run. There's no horizontal movement to go from one point to the other, just the vertical movement. All right, that about does it for this video. Thanks for watching, and I'll see you next time.